All right, let's jump straight into this explainer. If you're managing a VMware infrastructure, you already know that tracking down the culprits behind a sluggish virtual environment can honestly feel a lot like hunting ghosts. You know something's wrong, but you just can't see it. Well, today we're going to equip you to act as a proper IT detective.
I want you to ask yourself a pretty crucial question right now. Is your virtual environment secretly suffocating? Things like high latency, dropped packets, and crashed VMs, they can silently wreck your infrastructure, bleeding away performance and causing absolute nightmares for your users. But the good news is, today we're going to map those exact nightmares directly to the tools and strategies you need to actually solve them.
So here is our investigation briefing for today. We'll be covering the core troubleshooting toolkit, diagnosing storage and networks, finding evidence in logs, vSphere 8 performance enhancements, and finally, AI-driven automated remediation.
First up, Section 1, the core troubleshooting toolkit.
Okay, so you essentially have two main monitoring approaches here. On the one hand, we have ESTOP. This is your real-time command line utility when you need to really get your hands dirty with granular metrics for immediate bottleneck diagnosis. This is absolutely your go-to. It's kind of like staring directly at the matrix. But then on the other hand, we have ARIA Operations. This gives you a highly visual, predictive platform. It takes a much wider macro-level view, analyzing historical data to forecast trends and proactively catch issues before they blow up. So one is for getting into the weeds right now, and the other is for planning and preventing tomorrow's disasters. Now, when you are actually in the XTOP interactive mode, mastering a few specific keystrokes is hands down your fastest way to zero in on a bottleneck. Just hit C for your CPU view. That's going to let you check for ready percentage and scheduling contention. Press M to bring up your memory view to spot swapping and ballooning. Hit D for your disk view to monitor latency and I/O bottlenecks. And finally, N for your network view to catch packet loss and congestion. Seriously, just memorize these 4 keys, and you can instantly slice through all the noise to find out exactly what resource is causing your headache.
Moving right along to Section 2, diagnosing storage and networks.
Listen, if you're using that C command in ESTAB and top and you see your CPU ready time creeping above a critical 10% threshold, you found a smoking gun. What does that actually mean? Well, it means virtual machines are completely ready to execute commands, but they're literally just waiting in line because the physical CPU is too busy. This is a dead giveaway for CPU contention, which is almost always due to oversubscription. It's a huge red flag that you absolutely must never ignore. When you're troubleshooting storage latency, figuring out exactly where the delay is happening is everything. You really need to watch 2 distinct metrics here. If your device latency is over 20 milliseconds, that points straight to a problem with your physical storage hardware, stuff like your SAN, NAS, or vSAN array. Basically, the physical disks are just slow. But if your kernel latency is over 2 milliseconds, that points to an ESXi kernel I/O scheduling issue. In that case, the hypervisor itself is struggling to process the commands. Knowing the difference right off the bat tells you if you're dealing with a physical storage problem or a hypervisor issue, which is going to save you hours of misdirected troubleshooting. And this kind of precise methodology translates perfectly to modern network troubleshooting too. For complex environments, NSXT uses this really logical 3-step sequence to expose microsegmentation issues. Step 1, NSX Intelligence uses AI-based network flow analytics to spot an east-west traffic anomaly or security threat. Step 2, you fire up TreeSflow, which is this great tool that actually simulates packet flow from the source to the destination. And Step 3, by watching that simulated packet, you can identify the exact routing, firewall, or connectivity issue that's dropping your traffic. It's just an incredibly methodical way to untangle virtual networking. Let's dive into Section 3, finding evidence in logs. Okay, when the real-time tools aren't enough, you need the paper trail. Knowing exactly which log to check drastically reduces your troubleshooting time. There are 3 critical files you need to memorize. First, the VMware.log. This is for individual VM activities. So if a single VM fails to start, crashes, or has a configuration error, you look here. Second, the vmkernel.log. This one tracks ESXi host-level issues. If you've got hardware failures, VMFS storage errors, or CPU scheduling issues, this is your target. And finally, the vpxd.log. This is your go-to for vCenter management failures or cluster-wide high availability and DRS load balancing issues. You just need to figure out what level your problem is at, VM, host, or cluster, and then you know exactly which file to crack open. For example, if you're scanning that vmkernel.log and you suddenly spot this specific raw message, NMP, device connectivity lost, literally stop right there.
That is definitive evidence of a storage connectivity issue. It means your underlying SAN or NAS has gone down or disconnected from the host completely. At that point, you don't need to waste time checking CPU or memory. You need to immediately get your storage admin on the line or start checking your physical storage paths.
All right, Section 4, vSphere 8 Performance Enhancements.
So here is where the infrastructure itself is actually getting a lot smarter. With NUMA-aware scheduling, and NUMA stands for non-uniform memory access, by the way, vSphere 8 intelligently places virtual machines based on CPU and memory locality. By keeping a VM's memory physically close to the exact CPU core it's using, you drastically reduce memory latency. And that is absolutely crucial for high-performance applications that completely rely on split-second, low-latency memory access. And the Distributed Resource Scheduler, or DRS, has been enhanced right alongside this. vSphere 8's DRS now intelligently factors in real-time VM demand, that NUMA locality we were just talking about, and memory sharing efficiency. Instead of just reacting blindly to random CPU spikes, it looks at the whole picture to ensure much smarter workload placement. Ultimately, this is what stops those transient, temporary resource spikes from causing unnecessary and totally disruptive VM migrations all across your cluster.
And finally, Section 5, AI-driven automated remediation. Now, this is where things get truly futuristic. Automated Root Cause Analysis, or RCA, is an AI and machine learning-driven problem detection feature built right into VMware RA operations. It continuously monitors your environment, and when a performance anomaly pops up, it automatically identifies the root cause for you. By using machine learning to predict resource imbalances, auto-suggest better VM placements, and even optimize storage policies, RA Operations practically eliminates the need for manual log analysis. It's a massive leap toward a truly self-healing infrastructure.
Which brings us to a pretty vital question to end on. With AI now auto-remediating issues, predicting imbalances, and telling you exactly what went wrong, how will your role evolve? Because as infrastructure transitions to this self-healing model, the IT administrator's focus really has to shift. You're going to spend way less time doing manual detective work in the command line and a lot more time on strategic optimization, architecture, and driving real business value. It's a pretty exciting frontier, honestly. Thank you so much for joining me for this explainer, and I hope you leave today feeling fully equipped to go out there and conquer your virtual environments.